Okay, so I'm going to have my screen a little differently today because I am stupid and forgot to bring my polyatomic ion sheet to the house. Usually I do these recordings at home, but I do these recordings at school, but I'm at home right now. So I forgot the polyatomic ion sheet, so I'm going to kind of have it presented on the screen because we will refer to it. And then the PowerPoint isn't going to be like it usually is. I'm just going to slide down in the PowerPoint as we go. So yesterday we talked about just a brief introduction of what did we talk about yesterday? A brief introduction of naming compounds. My goodness. So today we're just going to go from name to formula. So on the test, you're going to be given names to formulas. You're going to have to do formula to name. You're going to have to do ionic compounds, covalent compounds, and acids. So today we're just going to start off easy and do names to formulas. So basically by the end of today, I want us to be able to identify polyatomic and monatomic ions. So basically if it's on the periodic table, it's monatomic ion. And if it's on our little sheet here, it's a polyatomic ion. So that's easy to identify. We're done basically now. But and then I want us to be able to write the chemical formulas and names for ionic compounds. So forget covalent compounds right now. We are only going to talk about ionic bonding and how to write the formula given a name. So Okay, so rules for naming formula. Rules for formula writing. Basically, since ionic compounds are neutral, so since even though ions have a charge, so for example, like we talked about yesterday, potassium having a +1 charge and nitrogen having a -3 charge, despite them having charges, the actual compound that they create, the K3N, this is neutral. So you've done something wrong if an ionic compound is not neutral, okay? So that's basically what that paragraph is saying, is that even though these both have charges, together they should be neutral. So since they're neutral, all we have to do is find how many you would need of each. So for example, today what we're doing is they're going to give us the name. So for example, pretend we were given So for example, today what we're doing is they give us a name and we had to come up with this formula right here. So all we have to do is look at the periodic table or this polyatomic charts. Literally this whole unit is super easy. Okay, so let's go to the first example. Actually, I'm not a fan of how the PowerPoints explain how to write this. I feel that I know a better way. So I want to show you today on my notes and just kind of show you how I was taught in college how to do this. I feel that's just easier. So how the PowerPoint shows you, we're going to go to the first example. They just give us magnesium and chlorine, okay? So they just give us those two and they say, what is the formula? So they give us this without the charges and they want this. So magnesium and chlorine, magnesium has, according to the periodic table, a +2 charge. Chlorine has a -1 charge. So magnesium has a +2 charge, chlorine has a -1. And the PowerPoint says, okay, just list them down here until the two charges will, cancel each other out. So you have +2, so you would need -2 over here. So Cl I don't even have my whiteout at home. So Cl -1, okay? So they do that, and then you would have +2 here, -2 here, and then those two cancel out, so you have 1 magnesium here and 2 chlorines here. So that's how the PowerPoint teaches you, and that's fine. But how I learned it, and how I would suggest, you can do either one in the test. I like to write the two ions that I have, magnesium +2, chlorine -1, and I do the cross method, so I just bring it down here. So basically this one goes down here, magnesium, and we don't write the 1, right? We never write the 1. And then this +2 charge goes down here. So to me, this is easier than doing this. If you like this method better, do it. If you like this one better, do this one. For the first couple of examples, I'm going to do both, and then I tend to just do mine. I like it better. Okay, next example is aluminum and oxygen. So they just give us A, L, and O if we were to be looking through it as a test or something. So aluminum is right here. So aluminum has a +3 charge. Aluminum has a +3 charge. Oxygen has a -2 charge. So oxygen has a -2 charge. So doing it the way the PowerPoint suggests, so you have, these two aren't the same charges, so you would add another oxygen. So this would be -4 at this point. This is +3, so that's not going to work. And then you would add another oxygen, so that would be -6, and you would add an aluminum, and then that would be +6, and they would cancel out. So then you would know that it's Al. There's 2 aluminums and there's 3 oxygens. You could do it that way, but honestly, I know my way is better. This is how I do it. You just take these and cross them down, and it would be Al2O3, because the 3 would go down here, 2 would go down here, and that's it. It's the cross method. This is easier. So yeah, let's just blow through some more examples. Next example is calcium and sulfur. So calcium and sulfur, I'm just going to go ahead and do it my way. It's just quicker and less stressful. Calcium has a +2 charge. Sulfur has a -2 charge. This is going to be easy, but also a lesson learned here. So you would end up getting Ca2S2. So this is where you say, okay, I thought ionic compounds are supposed to be reduced to the lowest form. Yes. So if you can reduce it, reduce it. And this is one of those examples. So it would actually just be CaS. Okay? So make sure you know that in ionic compounds, you must reduce it. And that's where the other method tends to be better, I guess, than mine, because you would have seen that they would have canceled out anyways, and you would have counted only 1 each. So whatever. Do what you wish. Next is calcium, Ca, and then this weird thing, ASO4. So obviously, we know calcium, right? We know where to find it. That's easy. Calcium's on the periodic table. It's a +2 charge. So easy. Calcium with a +2 charge. Now, this ASO4, if you look at the actual computer, the PowerPoint section of the video, let's find it. Obviously, this is not going to be on the periodic table, okay? So we're going to find it. I found it. Here it is. It's right here, okay? So this is called arsenate. And you'll see the charge up here. It's a -3 charge. So AsO4 with a -3 charge. The parentheses will be critical if we have more than one. If we don't have more than one, if we only have one of these things, one of these polyatomic ions, the parentheses can be optional. But otherwise, if there's more than one, they are not optional. You have to use them. Mandatory. Okay, so this number will go down here. This one will go down here. So you have Ca3. This 3 goes here. And then, since there's more than one, we do need to put it in parentheses. ASO4, 2. Now, if you want to just be safe, this is just like pronouns in a lab report. If you want to be safe, if you're not sure how to do it or if not, it's always okay to have parentheses, okay? But the rule with parentheses, if you have more than one, if you have more than one of the polyatomic ion, you must put it in parentheses. If you only have one, it's optional. So to be safe, you can always put it in parentheses, but you will see it both ways, both on my test and IB test. It's optional, so just know that if you do it all the time, you might not see it all the time. Okay, next, let's see. Sorry, wrong one. Okay, chemical name to formula. So this is where we're starting our actual names. So if we were to be actually going through the PowerPoint, we would have been given just aluminum sulfite, okay? So we would have just been given this word, okay? And we would have to figure out what it is. Are we looking at a polyatomic ion, a monatomic ion? So it gives us just this. So aluminum, that's easy, right? Aluminum here, it's a +3 charge. That one's easy. Sulfite. If it ended in IDE, then according to what we learned yesterday in the lecture or the lesson, sulfide, this is sulfide, IDE, ending in IDE. Chloride, fluoride, oxide, bromide, iodide. So all of these, nitride, all of them are ending in IDE. This is not. So sulfite, this is a common mistake my kids make every year. Sulfite is not this, okay? Look on your the screen where the PowerPoint is, and we need to look at this chart to determine where sulfite is and what it looks like. So sulfite, if you'll just scroll down and look through it, you'll find it. And it's right here. So sulfite is SO3 minus 2. Okay, so SO3 minus 2, and now all you have to do is just bring the exponents down. Okay, so that is Al2 parentheses SO3 3. And because there's more than one sulfites, we are required to put these parentheses here. All right, moving on. The next example, obviously we already see all of the answers, but that's not our point when we're learning. I'm just going, what you would have started with, if I would have brought my polyatomic ion sheet home with me, is just the word silver sulfate. Okay, so silver sulfate. So yeah, silver is Ag, okay? That's easy. That's on the periodic table. Silver might have taken you a while because it's Ag and that's weird to you, just like gold is weird, Au, mercury is weird too. There's a lot of weird things. A lot of kids think this is copper, and it makes sense that this would be copper, and I don't know, but whatever. But either way, this is silver, so that's periodic table. So that's Ag, and oh, this periodic table doesn't have it. The periodic table you'll get on your test will have charges, okay? And if you look on the, what's it called? The PowerPoint, you'll see the periodic table type that I give you with that +1 charge up there. So that's how you'll determine the charge on the transition metals, okay? Obviously, all of these have that easy trend, +1, +2, +3, ±4, -3, -2, -1. And remember we said these are weird. They are weird. You will get a special periodic table. Anyways, so silver is a +1 charge. And sulfate. So again, this is not sulfate, okay? This is sulfide. Remember that, okay? If it's a monatomic anion, which means one atom ion that's negative, it's going to end in IDE, so iodide, bromide, chloride, fluoride, oxide, sulfide, nitride, phosphide. So this is not ide, this is 8. So that means it's on the polyatomic ion sheet. So here's sulfate. If you look at the polyatomic ion sheet, sulfate is SO4 with a -2 charge. Okay, so again, we're just going to bring our exponents down. So it would be Ag2 SO4. You can keep it like this, Or if you don't like it and you want to use parentheses, that's acceptable as well. Okay, we have a couple more examples and I think we're basically done for the day. So we have calcium bromide, and then we're doing lithium nitrate, and then we're doing nickel, CKEL. I always spell that one wrong. I always want to put it LE, nitrate, and iron 3 chloride. Okay, I'm going to get rid of the PowerPoint. That way we can see this further. Hold on. There we go. Okay. So let's just go through these and then we'll be done for the day, okay? All right, so calcium bromide. So calcium is obviously on the periodic table. It's right here. It is in an easy to recognize group trend. Calcium is a +2 charge. Calcium is a +2 charge. Bromide is, it ends in IDE. So bromide is right here. It's a -1 charge. It's monatomic. So you just bring the exponents down, and the answer is CaBr2. That's it. Lithium nitrate. So lithium, so basically guys, the cation, remember how I told you if you look at the polyatomic ion sheet, the only positively charged cation that we will use in 10th grade and in IB is ammonium, okay? So that's all you have to know. There's others in the, in the world. If you go to be a, you're a chemist, you'll find that out later. But I mean, for our purposes and IB purposes and most of college, if you're not going to go actually be a chemist, ammonium is the only positive polyatomic ion that you will use. So basically all of these will be atoms on the periodic table that you can just grab the charges off of. It's the anions, you have to kind of stop and think a second. So lithium, here in that first group all has a +1 charge. So lithium with a +1 charge. Nitrate, if it was on the periodic table, this would be nitride, IDE, so it's not. So now we look at the polyatomic ions sheet and we try to find nitrate. So nitrate is right here. NO3 with a -1 charge. Okay, we can bring these down, or most of you can already see it's going to be a 1-to-1 ratio. So we actually don't have to do anything but write their names again. Just like that, lithium nitrate, okay? 1-to-1 ratio, you can put the parentheses if you want. Those are optional at this point. All right, so nickel 2 nitrate. So if you guys see this Roman numeral, don't be scared. It's actually helping you out. It's telling you what charge this nickel is. So when I do give you the actual periodic table that tells you the charges here, you'll see there's multiple charges sometimes for each element, and some of them up to 7 different charges. So that can be annoying. So you'll actually be thankful for these Roman numerals because they literally tell you the charge. So nickel would be a +2 charge. And nitrate, so nickel here, nitrate, this would be nitride, so no. Nitrate, we look at the, what's it called? Polyatomic ions. So nitrate, that's what we just had up here. So it is NO3 with a -1 charge. So you would just bring them down. So the answer would be Ni, but we don't write 1, right? It's going to be 2, so I'm going to put parentheses. NO3, 2. That's our answer. Same thing with iron. Iron's element symbol is Fe, and you can tell this has a +3 charge by the Roman numeral 3. Will these two ever be a -2 or minus charge? No. because it's a cation, it's metals. Metals are always positively charged. So don't think, oh, is it positive or negative 2 or 3? It's always positive, whatever that Roman numeral is. So this iron will be +3 charge. Chloride, so I know that that is here. This is chloride, so it's a -1 charge. Okay, so these go down here. And we have Fe1, but we don't write the 1, Cl3.